solving a system of 3 equations with 3 variables can definitely be a tedious process. It can cause headaches, it can be very frustrated, but as long as we're patient, as long as we commit to persevering, these problems aren't going to be too bad. It's just going to involve a lot of multiplication and addition. Really, we're going to be using elimination repeatedly to kind of whittle this problem down and work through it. So make sure you're as organized as you can be. I'm going to do this problem in colors if you want to grab a couple of colors to do as well. That may help you organize it. Just be very careful with your work, be very patient, and kind of check your work at each step and go through this carefully. And these won't be too bad to solve, I promise. So we're going to do this problem in phases. Phase 1 is I want to get rid of one of my variables. It's whatever you see. Like I tell people, just I don't know how to start. What do you see? Like what's something you can do to add 2 equations together to get rid of something? There's no real guidelines at the beginning other than I want you to get rid of some variables. So a lot of people don't like that. They want more specifics, but there isn't. Just get rid of something first. And so there's many ways we can start, but what I'm noticing is that if I were to take this bottom equation and multiply it by -3 and then combine that with the middle equation, I should be able to get rid of my y's. Okay, not the only way we could start, but that's what I saw. So I'm going to go ahead and do that. So I'm going to write my new equation, the bottom one multiplied by -3. So -18x plus 3y minus 12z, and I like to put a little slash through my z so they don't look like 4s, and then equals 3. Okay, again, kind of pause at each step that you do and make sure what you did made sense, you didn't have any errors, because one little tiny sign error will screw up the whole problem, and it's going to be next to impossible to find that mistake. So let me go ahead and add that to the middle equation just the way it was. So let me rewrite the middle equation. It was -2x minus 3y plus 5z equals -14. Then I wanted to add those 2 equations together because I knew I would get rid of y. So my new equation is -16x. The y's are eliminated. That's what I wanted to have happen. Minus 7z, and then equals -11. Go ahead and box that equation. We're going to need it later. Okay? At this point, switch colors. We're still in phase 1, but I want to switch colors. The second part of phase 1 is go back to the beginning, go back to your original 3 equations, and now find another way to get rid of that same variable using a different combination of equations. So for example, we chose to get rid of y. We need to choose to get rid of y again. Some people like get rid of y and then they get rid of x and they run into a problem, they don't know what happened. Get rid of the same variable twice using a different combination. So we had used the bottom 2 equations. So I need to either use the top 2 or the first and third. And what I'm noticing is if I were to multiply the second equation by 2 and then add that to the top equation, that should also get rid of y. So let's go ahead and do that. Remember, this is still phase 1. Hopefully you've switched colors if you're doing this in colors. So the bottom equation now multiplied by 2 gets me 12x, and again, kind of check your work at each step, minus 2y plus 8z equals -2, and I want to add that to the top equation just the way it was. So let me rewrite the top equation, which was -4x. So my writing's getting a little sloppy, and that's going to hurt me. Be as neat as possible. Plus 2y plus 3z equals 1. And let's go ahead and add those 2 equations together and see what happens. So the x's add up to 16x. The y's are eliminated like I wanted to. What I wanted to have happen, I want to get rid of the same variable twice. Plus 11z, and then equals -1. Again, box that equation. We're going to need it. In fact, we're going to need it right now. Okay, we're done with phase 1. Take a nice sigh of relief, or breath of relief. We're on to phase 2. What I've done now is I've made 2 boxed equations, and I've made 2 equations that have 2 variables, and guess what? You know how to solve those. We've really made now a system of 2 equations. So using what we talked about last week, let's do elimination or substitution, probably elimination, again. So phase 2 is take your 2 boxed equations and repeat the process. So we were really lucky, and look what happened. I had -16x and +16x. That was a total coincidence. That won't always happen, but since it did, let's take advantage of that. So I actually don't need to multiply anything. I can just add these 2 equations just the way they are to get rid of x. So I'm in green now, so I'm going to rewrite this just so I can see my steps. So my phase 2 part of the problem is I'm going to take -16x minus 7z equals -11 and add that just the way it is to my other boxed equation, 11z equals -1. I didn't need to do any extra multiplying, which is a total coincidence, but the x's drop out. Negative 7z plus 11z is 4z, would be equal to negative 12, and then divide, and I get z equals negative 3. Okay, circle that. You don't want to lose these answers. These problems are a lot of work, and you don't want to lose that answer. So congrats, you found one variable, one down and only two to go. The good news is this was the longest part of the problem. From here, everything else is gonna fall into place. Once you find one variable, everything else is easy to find. So I'm gonna switch colors one last time for phase 3 of the problem. Phase 3 is to work your way backwards. We've kind of been working our way along the page, and now what I want to do is start kind of flowing backwards. So I found my first variable, z is negative 3. Let's go back to one of the boxed equations and plug that value in just like we would have done if this was only a regular system of two equations. So pick either boxed equation and plug in the variable you know. So I'm going to find x next, it looks like. So 16x plus 11, oops, my writing's getting sloppy again, plus 11 times negative 3, which is what we just learned that z was, would be equal to negative 1. If I solve that, I get 16x minus 33 equals negative 1, so I'll add 33 to both sides, so I get 16x equals 32, which means x must be 2. Again, circle that. You don't want to lose that in all your work. So there's our second variable, 2 down and 1 to go. So we have x and we have z, and you may find these in any order, who knows. Now that you know z, we're flowing back to the beginning. So once we know 2, go all the way back to the beginning of the problem and plug in both of those variables, for, both x and z, to find our remaining variable. So it does not matter which equation, which of the original 3 you pick. I'm just going to pick the top equation because there's no negatives, there's minus signs in it, but it should work in any equation. So plug in everything you know in that top equation to solve for your remaining variable. So 4 times x, which we now know is 2, plus 2 times y, that's our only remaining variable, plus 3 times z, which we know is now negative 3, would be equal to 1. Okay, so let's go ahead and solve that. I'm going to have 8 plus 2y minus 9 would equal 1. If I combine some like terms, I've got 2y minus 1 equals 1. I'll add 2 to both sides and finally divide. And there we go. There is our final answer. I get y equals 1 after all that work. So if you gave me those 3 answers circled like the way they were, I would be so proud. I'd say that's awesome. You did a fantastic job on a very long, very time-consuming process. But ideally what I want to do is I still want to write that answer as a coordinate. It's no longer called an ordered pair, it's called an ordered triple, but it's the same idea. So it doesn't matter the order you found them in, it always goes x, y, and z. So our x was 2, our y was 1, and our z was negative 3. So circle that. Ideally that's what I'm looking for, and then be proud of yourselves. Look at that problem, an entire screen worth of work for one single problem. But as long as you're organized, like we said, as long as you're patient, nothing about that problem should have been hard necessarily. It was all just adding and multiplying. But it's definitely time consuming. One little mistake and the entire problem is messed up. So be very, very careful as you're working through these problems. If you do get to an answer that is a mistake, or you know something went wrong, my advice, you're not going to want to hear it, but my advice is rather than look for your mistake and all that work, just erase and start over. That may be your best bet, your most efficient way to do these. So good luck with these problems. I promise you can do them. They're not impossible. I believe in you. I know you can do these. So go solve some systems of 3 equations.